Uh, okay. Good afternoon. So we start the next chapter, which is geometry. But there are two parts for this geometry. The first part is analytic geometry. So by analytic geometry, I mean a combination of algebra and geometry. So we already had this in Math 1C. When you want to, when you have a point in geometry, a point is something like this. A line is something like this, you know. A line segment, these are shapes. These are pure geometry. But when I talk about analytic geometry, it means that I want to use the power of algebra to be able to solve geometrical problems. So for example, the point is no longer this shape or this trace of my pen on the whiteboard. A point in analytic geometry is what? A pair of numbers. So for example, if I want to address this point to you, I just give you two numbers, yes? The number, okay, so A is my point. Let us say that this is 5 units, and let us say this is 3 units. A is a point from geometrical point of view, but in analytic geometry, which is somehow a combination between geometry and algebra, I can write the point with two numbers. I can address you the point with two numbers. One is called the x coordinate, and the other one is called the y coordinate, yes? I would say that the point with coordinates 5 and 3, and by convention, the number sitting first is the x, the number coming next is the y. That's the convention. The first number is the x coordinate and the second number is the y coordinate. So this is not something new. You had it even from going to school and you also had it in Math 1C. So this is analytic geometry. So you see, I say the point A with coordinates 5 and 3. Of course, 5 and 3 are numbers, but the point has a geometrical concept, abstract concept in your head. So we are just reconciling, we are just gluing together the ideas from algebra and the ideas of geometry, hoping that I can use the power of algebra to solve something in geometry and the other way around, to use the power of geometry sometimes to solve problems in algebra. Okay, that's the idea. We had something, for example, this was the beginning, but we also in Math 1C we learned about lines. Lines are shapes like this. A straight line is a shape in geometry, but in Math 1C we learned that we can represent it by an equation, which is in the realm of algebra. Yes, we learned that an equation of this type, a line of this type has an equation in algebra like this. Yes, and then k is the slope, which has something to do with the slope, and m is the y-intercept. So for example, I can say that if I have this line here, if this point is with coordinates 0 and m, the x-coordinate is 0 and the y-coordinate is m, this can be represented of this one. Okay, and then what is the meaning of k, a slope? So in this case, a slope is positive, and if the line is horizontal, the slope is 0. And if the line is the other way around, like this, the slope is negative. And we also learned in Math 1C that if I have a vertical line like this, the slope is not defined. So all the lines, the equation of all possible lines are of this form except vertical lines. It doesn't mean that vertical lines are hard, but they have a different story. For example, if I give you this line, and I tell you this point is point 3, and you see that this line is perpendicular to the x-axis. If I ask you to write an equation for this line, what that is? Not y. X is equal to 3. So if the line is vertical, in the equation of the line, you only see x, you don't see y. But any other lines have an equation of this form in which you see y and x. But if I have a horizontal line, what happens? K value is, the slope is 0. If the k value is 0, you don't see x. So if you don't see x, it means your line is horizontal. If you don't see y, it means that your line is vertical. If you see both x and both x and y, it means that your line is oblique. Yes. Okay, so if you have both x and y, your line is oblique, is inclined. If k is positive, this is inclined in this direction. If k is negative, it is inclined in that direction. Something about lines we learned in Math 1C, do you remember about by looking at the equation of the line, how can I understand the lines are parallel and how can I understand the lines are perpendicular? Perpendicular means what? Two lines are said to be perpendicular if they intersect each other at one point and the angle that make is 90 degrees. So these lines are called perpendicular. Okay, so if I give you two lines, let me write line number one, y is equal to k number one x plus m1. And I give you another line L2, y is equal to k number 2x plus m number 2. So do you remember from Math 1C, L1 is parallel to L2 if and only if what happens? How do you know? By looking. Of course, you can draw the pictures and see if they are parallel or not, but another way to understand that is to compare k values, yes? If the k values are the same. So two lines are parallel. I'm going very fast because we had this before. So remember, L1 is parallel to L2 if and only if the k values are the same, yes? But do you remember we also had this in Math 1C, when these two lines are perpendicular. This is the symbol I use for parallelness. This is the symbol I use for perpendicularity, yes? So two lines are perpendicular means this. Yes, what happens? If and only if what happens? No, different, but of course this is also different. But this angle is not 90. Yes, I want to have the angle 90, so that's very important. I don't know how much you remember from Math 1C. Yes?
K value is the negative counterpart of the other K value.
Yes, so in other words, the product of K values is not zero, as you said, minus the reciprocal, not counterpart. Yes, minus the reciprocal of this. So this is very important. I want you to remember, at least write them somewhere in your notebook so that you can use them. I don't know if it is in the formula sheet or not. I don't want to go through the proof of them. We discussed about the proof of them, why this is working. I'm just using them. So this is what we had so far, okay? Very crash review of what we had so far. But today we want to learn two new formulas, extremely simple formulas, but very powerful. One of them is called the distance formula. It's very simple. The idea is very simple. So the distance formula. What does this mean? In geometry, if I give you 2 points and I ask you to measure the distance of these 2 points, you have to have a tool. For example, you take the ruler and measure the length from A to B. This is in geometry. But in analytic geometry, I can use the power of algebra to calculate everything exactly and precisely, okay? Here, if I take my ruler and put it here and calculate the length, I cannot calculate measuring the length, but the precision is limited by the precision of the instrument that I'm using. If I have a laser beam available to measure the length, I have a better number than just having this crude ruler, yes? But the power of algebra is that it gives you the exact value, 100% precise. So how? So in geometry, the problem is simple, but I want to solve this problem in analytic geometry. In analytic geometry, I do not have points as these shapes. I don't know what to call them. Let us say this is a point shape. I'm not having this. I have a pair of numbers for A and a pair of numbers for B. So if I have my coordinate system here, yes, for example, let us say that the point B is here with two coordinates, x sub B and y sub B. What does it mean? It means the x coordinate of the point B, the y coordinate of the point B. Now let us say that I have another point here, for example, A. Let me draw it here. I have another point A here, for example, and I have XA and YA. This means that I have these 2 points, XB and YB. I have 2 points, 1 point here, 1 point is there, and I want to find the distance between them, and I show it with D. That is the one that they use in formula sheet for you. So the distance between these two, I want to know what that is. So what does it mean? I give you these numbers, it means that I give you where the point A is. I give you these numbers, it means I give you where the point B is. And then I ask you find the distance between these 2 points. Okay, so yes.
It's square root of xa minus xb plus x xya minus yb.
No, there is one missing point on it. Power of 2 again. The square root of power 2. Why? Because you know why? Let us say that if I say this is xa, it means that from here to here is how much? If this point has x coordinate xa, this means this length is xa. And then this length is how much? From here to here is xb. So now if I ask you what is this length, you can answer. Because you say that the longer one minus the shorter one is exactly the one that I want here. So this is nothing except x of a minus x of b. Agree? And I do the same thing for y coordinates. Yes? What I will do, I will say that what is this one? From here to here is how much? Everyone? Y of a. This is the y coordinate of my point. And from here to here is how much? Y of b. But let me ask you, what is this distance then? It is the longer one minus the shorter one. Yes? But now look what happens. It becomes a right angle triangle, you know, here. This is a right angle triangle. I hope that you agree with me, this length and this length are the same. So if this is xa minus xb, this is also xa minus xb. And if I ask you what this length is, this length and that length are equal. So it is ya minus yb, this is also ya minus yb, yes? But then you have the Pythagoras theorem, because why I can use Pythagoras theorem? Because this is a triangle, and one angle is 90. So it's a right angle triangle, so I can use the Pythagoras theorem. The Pythagoras theorem tells you that the hypotenuse squared, d squared, is equal to this length squared, and that is what you missed, Hasbulat, yes? There is a power of 2 here. And then plus this length squared, which is ya minus yb squared. But I was looking for d, so I take the square root. But you know that in algebra you have to be careful. When you take the square root, you have to put plus or minus. But here it is not necessary. Why?
Distance cannot be negative.
Yes, distance cannot be negative. Based on that, I don't put plus and minus. So I write xa minus xb to the power of 2 plus ya minus yb to the power of 2. So this is the formula. I have it in my memory. I recommend you to have it. If you don't, it is in your formula sheet. But I need you to understand when you have to use it. When it is suitable, if I give you 2 points with the coordinates and I ask you to find the distance between them. You just read the numbers from what I have given to you, put them in this formula and calculate them. One common mistake, I don't know why, how many times I have to mention this. Many people think that mathematicians are stupid, so they immediately simplify this square root with these twos. Okay, don't you even think twice that if this is the case, why mathematicians they bother to write this? This is not just for decoration, is it? Some people, I don't know why, they want to calculate this. They say that the square root of power 2 will eliminate this power of 2, and the square root of this power 2 will eliminate this power 2. So they think they start from here, but they calculate like this, which is wrong. Yes, be careful about that. If you think you make a mistake in the future, write it and cross it over. Why this is mistake? The common mistake is this. a squared, I have told you several times, square root of a squared times b squared, you can write a times b. This is, I think, the source of this error. They, by analogy, they think that this is also the case. This is true, but this is false. Okay, so be careful. This is what you have to write. There is no simplification unless when you calculate this and add them up, if for example it becomes 25, the square root of 25 is 5. Otherwise you have to keep it like that. Yes.
Can you use that formula if the right angle triangle is in the negatives?
Yes, that's what I'm just, I intentionally drew it, a little bit of cheating here. I put A on the right and above and B below. But it doesn't matter, you know. For example, let us say A is here, B is there. Then you have to write xb minus xa and yb minus ya. Yes, in principle you have to switch them, but you don't need to be worried about that. Can you tell me why? So it doesn't matter if A is above B or on the right hand side of B or the other way around. Your formula is always this. Can you tell me why it is not sensitive to replacement? Let us imagine, let us replace. What happens? If I replace these two, the new one and the old one differ by, so if I ask you what is the difference between A minus B and B minus A? Of course, hopefully, if I say what is the difference between A plus B and B plus A, what's the difference between these two? Nothing. Is there any difference between these two?
Yes.
They are not the same. Why? Because here A is positive, B is negative. But here B is positive, A is negative. So they cannot be the same. But they don't differ that much. I mean, there is a relation between them always, yes?
So, but it's a raised to the power of 2, right? So
Yes, that's the answer to this question. But can you say what is the difference between them?
one is negative.
One of them is the other one, so negative of the other one. They are not the same. These two are the same, but they are not the same, but they differ by a minus sign. Why is that? Because if you multiply the minus sign back, it becomes minus b. Minus times minus becomes plus a, so that's correct. So what happens here, if you replace them, it is not equal. I agree with you. It gives you a minus sign, but minus sign doesn't matter here. Why? Because as Shah said, this even power of 2 will kill that minus sign that you pull out. So be on the you are on the safe side. So don't worry about that. If you want to find the distance between 2 points, it doesn't matter. So what matters is the difference of x coordinates squared plus the difference of the y coordinates squared. Which one is first, which one is second, for the purpose of this calculation is irrelevant. Yes? Is that understandable? Okay, for example, let me give you a simple example. For example, I give you the point A with coordinates 1 and minus 2, and I give you a point with B with coordinates, I don't know, minus 3 and minus 5, for example. And I ask you to find the length of AB, the length. I mean, they can ask you different questions. They can ask you what is the distance between them. They can ask you what is the line, what is the length of the line segment AB anyway. So you know that you have to calculate using this. So what you do, you write AB, for example, is equal to square root of, you have to fill up this formula. Yes? So what do you write here? You write the difference between the x coordinates. What do you write here? You write the difference between y coordinates. I recommend you don't do it in your head, okay? The x coordinate here is 1 minus, the x coordinate here is minus 3 itself. Be careful. And the difference between y coordinates, the y coordinate here is minus 2, minus the y coordinate here is itself negative. So these two minus signs that I am now emphasizing on are from the formula. But these two minus signs are because these two are minus. And then you continue. 1 minus minus 3 is what? Is 4. 4 to power 2. Minus 2 plus 5 again, because minus minus 5 is plus 5. And then it becomes what? 3. Okay, the common mistake I told you, people sometimes write 4 plus 3. It's not correct, yes? You have to write 4 to power 2, which is 16, 3 to power 2, which is 9, and then add them up, and then take square root if possible. If not, leave it like this. You don't need calculator. If it is, for example, 26, I just simply write square root of 26 and leave it. But if it is a friendly number, I continue until I find the answer. So is that clear? Okay, so that is not hard. Um, so for example, let me give you a little bit better problem. So let us say that I have 3 lines, line L1 with this equation, y is equal to 2, and then I would say L2, y equals to 4x, yes, and then so L3, so let me write y is equal to minus x plus 10. It's a better question now. So I give you 3 lines, and I say that these 3 lines make a triangle. So let me see. They make a triangle in the first quadrant. Okay? So these 3 lines are given. They form a triangle. I want you to find, for example, the area. Or I want you to find the perimeter, omkrets, yes? So you want to find those things for this. It's a better question. It's a combination of Math 1C problem and what we learned in system of equations and this formula together. So we want to solve this problem. Okay, is the question clear? So let us have a rough picture. You don't need to be very precise, but it's better to draw something in front of you. Okay, so the first thing that you do is to sketch a picture so that you understand what's going on. I hope that I could imagine it right, otherwise I have to change the numbers a little bit. So the first one is y equals to 2. You know the graph of that function. What is that? Y is 2 is equal to, is a horizontal line. Yes, y is 2. So I would say that 1, 2, this is 1, 2, so that is y equals to 2. Yes. Okay. And then if you want to find this line, do you remember in Math 1C I told you that you just need to find 2 points. For example, put x equals to 0, y also becomes equal to 0. So that is 1 point of that new line. This line, let me write it L1. This is L1. And then I emphasize here that this is 2. For drawing a picture of this one, I, for example, choose 2 points, yes? Whatever you choose, it doesn't matter, but let us keep the numbers small. If I put 0, y becomes 0, so 1 point is here. If I put x equals to 1, y becomes 4, so 1 and 4. So if this is 2, let us say this is 3, and this is 1. So that's another point. So I need to connect them. Yes? So for example here. Yes. So this is another line. This line is L2. Okay, so it might be this number 10 is a little bit crazy. So let me make it. Let me make it. Four. Yeah. Four. Let me make it 5 or 6 is a yeah. So number. This is 2, 3, 4, 5, 6. I can fit 6 here. So let us write 6 because otherwise it will go beyond the board. Let me change it to 6. Okay, if I want to know L3, what should I do? Again, I set up another table. For example, if I put x equals to 0, y becomes 6. Yes, I don't know which one you want to choose. For example, let me put 1. instead of x, then it becomes 5. So I need to find these 2 points, 0 and 6, 0, 2, 3, 4, 5, and 6 here. This is 1 point, and the other point is x1, y5. So this is 1, 2, 3, 4, 5 here. Yes. Yes. 3, 4, 5, and that one is 6. Sorry for the mess, but this, let me continue so that you are not confused. Yes. Okay, so that point and that point should also be connected. Something like that. So I can draw it with GeoGebra so that you can have a better idea what is going on. So this point is what? This line is L3. Okay, so this point, this line is L2. So this is L1, this is L2, and this is L3, and this is your triangle. Yes? Now, what you want to do, you want to find the area of that triangle, yes? And you want to find the perimeter of that triangle.
Can't you use like the geometry before with similar triangles? You see that smaller
Yes, sir?
that smaller triangle is in a bigger triangle. So can't you like?
No, it is not in a big. So I mean, no, I don't recommend that. If it works, yes, do it. But this is not something I can rely on. Yes. Okay, so at least I hope that you understand what is going on. You are not confused. So don't worry about these things. So I can clean them. I don't need them anymore. I just need you to concentrate on 3 lines. And the 3 lines, when you draw them, it makes a triangle for you. And we want to find the area of this triangle. So what should we do? I would recommend you to find the perimeter first. For finding the perimeter, what do I need? Let me call this A, let me call this B, let me call this C. I need to find this length, I need to find that length, and I need to find that length. And then add them up. That sounds easy. But finding the length was also not hard because we just learned. In order to find the length, I need the x and y coordinates of my points. That is the only thing that you need, because the points are not given to you, but the lines are given to you. So you need to ask yourself, how can I use lines, equation of lines, to find the coordinates of points? And when you have the coordinates of points, then you can use the distance formula to find the length of each piece, yes? Okay, now let us concentrate to do some simple jobs. So can you tell me, for example, if I want to find the coordinates of the point B, what should I do? Usually, the hard questions are not drawn in the grid paper. So you cannot rely on just looking and guessing the numbers. So you have to be able to calculate them. So this means that you need the knowledge in chapter 2. Yes? So this is one equation. This is another equation. And the point B is the intersection point. So do you remember in chapter 2, if I want to find the intersection points of 2 functions, whatever, I need to solve A. I need to say a poem, yes? So what should I do? I need to solve a system. Yes? So I need to open a system. L1 is y equals to 2. L2 is, what is L2? Is 4x. Yes? If I solve the system will give me 2 numbers, one for x, one for y. These are the coordinates of the intersection point. But the system is extremely solved. This is even not E-level question in chapter 2. Yes? y is already given, it's 2, so you just put it here. So 2 becomes 4x, x becomes what? 0 comma 5. So don't get confused. Immediately write this b. What are the coordinates of b? The x coordinate is this number. What is the y coordinate? 2. So yes, that is one of them. But of course, you have to do it once for C, once for A to find all of them. Okay, so let us do that. This is for finding point B. So let me write B. This is for suitable for finding B. For finding C, which ones are suitable? Line 3 and line 1. Line 1 is already there. Line 3 is what? Y is equal to minus x plus 6. I have to solve the system. But instead of y, I can immediately put 2. So then it means that x is 4. So then it means the point C has x coordinate 4 and the y coordinate still is 2. Yes? So these type of problems are not hard. Yeah, but you have to be patient a little bit. And then the final point is point A. I need to find point A. So for point A, which system is suitable now? Line 2, which is, which one is that? Is y equals to 4x. And line 3, which is y equals to minus x plus 6. And I want to solve the system. But still, I use the substitution method. Y is equal to 4x. I substitute it here. So it becomes 4x equals to minus x plus 6. I move it to the other side. 5x becomes 6. And then x becomes 1 comma 2. Yes? But x is 1 comma 2. So what is y then? Y is 4 times larger. So it's 4 comma 8. The reason I am using decimal points because these are exact values. Otherwise, I have to keep fractions. So finally, I found my A. What is my A? My A has 1.2 as the x coordinate and 4 comma 8 as the y coordinate. So everything is now known to me. Okay? Now what I want to do, I want to find the distances. The distance from A to B, which is the length of AB, and the distance from A to C, and the distance from B to C. Okay, and then I have to use the distance formula 3 times. So the perimeter. So the perimeter, so I think there should be an E. I will check the spelling, I'm not sure. So to find that, I have to find AB, I have to find AC, I have to find BC. Okay, what is AB? AB is a square root, AC is also a square root, AC is also a square root. I have to fill up these gaps. These are the gaps I have to fill up. To fill up these gaps, I need x and y coordinates of points A and B. I have it on the board. So A is A and B. The difference between x coordinates, 1 comma 2 minus 0 comma 5. And the difference between y coordinates, 4 comma 8 minus 2. So you can use your calculator, of course, for these problems, but let me see, as much as I can, I continue with my head, otherwise I use the calculator. So this is 0.7 to the power of 2 is 0.49. And this one is how much? 2 comma 8, but I don't know. 2 comma 8 to power 2 is what? Let me calculate using the GeoGebra. This is 784. So what is the answer now? You can calculate this as well by GeoGebra or your calculator. Okay, if you round it up to 1 decimal point, it becomes 2, 9. Approximately, of course. So you see, everything was in Math 1C and the previous chapter. The only new thing is this formula, only. Today's lesson is just this line, nothing else. Okay, so go here. Here I need A and C. Oh, I made a mistake, yes? No, that's correct, that's correct. Now I need to calculate AC. A is this one, C is this one. So I subtract them. So I would write 4 minus 1 comma 2. You see, I am not sensitive which one is first. It doesn't matter. Yes? And then the other one is 2 minus comma. So I would write this one minus 2. Okay, and then what is this number? So I can put this in GeoGebra directly. So this is 2 comma 8 to the power of 2. And then again 2 comma 8 to the power of 2. So let me put this in GeoGebra and find the answer. Yes? Why? I told you that it doesn't matter because the x coordinates are 4 and 1 comma 2. It doesn't matter which one I write first, which one second, because of the even power. You are right. In principle, I have to write this the other way around. X of A is, you see on the board, is 1.2. X of C is on the board is 4. So I have to write 1.2 minus 4. But I was not very worried about the order because at the end, this power of 2 will take care of it. But if you want to be organized, write them in order. Yes, the same story. The numbers are important here. So let me just now put the number here in my calculator. So this is the square root of 2 comma 8 to the power of 2. So it is 3.9. It's 3.9. And finally, this one, if I want to find it, this is the difference between B and C. B and C are these numbers. So 4 minus 0, 5. And then 2 minus 2. So 2 minus 2 is 0. So the answer to this is simply 3, 5. Yes? Okay, and the perimeter, let me also double check this. That is correct. Perimeter, yes, that's correct. This is the spelling. So that is omkrets, I think in Swedish you say. So BC is 3.5. And now if I want to find the perimeter, what do I do? So the question mark is 2.9 plus 3.9 plus 3.5. And then if everything is in centimeters, so you can write the length units, because if I want to find the perimeter, it's better to write the units. And I'm lazy to add them up. You can add them up yourself. But what about the area? How can I find the area? The area in this problem is easy, but I can give you a harder one in which the area is hard to find. But the area is easy here because I am lucky that one of the lines is horizontal. Okay, so if I want to find the area, what do? Do you remember? I consider this as my base, and I know the length of the base. I just did it. This is the length. And I need something more. What do I need more? The height. The height is from here to here. But that is extremely simple because I am lucky that one of them is horizontal. I will tell you if one of them is not horizontal, then what to do. But can you tell me what is this height now?
3.
Why? Because this number A was at what height? The height of A. Where is A? A is here. No, it's not 5. Remember, A is 4.8. So the height of A is 4.8, but here is 2. So the distance is how much? 2.8. Okay? So this height is 2.8, and this length is, I just did it, is 3.5. Yes? Yes? I will tell you. And then the area becomes what? So I would write the area. Is equal to 1/2 multiplied by the base. What is the base? The base is 3, 5 multiplied by the height. The height is 2,8. Okay, I don't want to calculate it. It is as simple. You just put this number in the calculator, you get area units. It is simple. So this is a very good example to understand this formula. So everything you see for solving this problem is not new. The only new is this formula. So understanding, graphing, everything we learned before. So I'm using those knowledge and I am adding something to it so that you can solve a new and harder problem. Okay, the motivation we got here, you do agree with me that we are lucky, otherwise finding the length is not hard, even if it is not horizontal. Because I find B, as I did, I find C, and I put it in my formula. Who cares if it is horizontal or not? Why horizontal part of it was important? Because if the line is not horizontal, I am in trouble, you see. For example, let us say that I have a triangle like this, and this line is not horizontal. Yes? Then the height becomes this. Okay? In here, I was asking, okay, this height minus this height becomes exactly the height I need. But I cannot do it here, yes? Because this height is from here to here, but I need that height. They don't have any good relation with one another. So I need to find a better way to understand how can I find the height. Is the question clear? Okay. But instead of doing it, I want to change the problem to make it simpler algebraically so that you are not getting confused. So I want to design this question for you. So, for example, let us concentrate on this line. Y is equal to, let me make it very simple. So 3x, and then I give you a point with coordinates 2 and 5. My question is, find the shortest distance from the point to the line. Okay? The shortest. Usually people don't talk about the shortest. The distance, they say the distance from A, let me call this line, line L. Okay? So what should we do? If I have a line, you see, if I have 2 points and I give you the ruler and I ask you to measure the distance between them, you know what to do. You take your ruler and join them, combine them, yes? And then you use your ruler to read the length. But if I give you a line and a point, and I ask you to find the distance from the point to the distance. Okay, so the question, be careful, this is very important. If I give you 2 points and I ask you to find the distance between them, this is not ambiguous. You take your ruler, put them next to them, and measure the length. But this is a little bit ambiguous, do you agree? If I give you a point, and I give you a line, and I give you the same ruler, and I ask you to find the distance from the point to the line, yes, what does it mean? Because, of course, this is one single point. If I want to take my ruler, you might say that, okay, I measure this distance. You might say, no, I measure this distance. You say, no, I measure this distance. which one is the distance between the point and the line. Okay? This is the shortest distance. When I give you a point, and I give you 2 points, there is no ambiguity. There is one number you can measure. But if I give you a point and a line, because there are infinitely many points on this line, you get a little bit confused which distance I have to measure with my ruler and say that is the distance from the point to the line. What is that? The answer to this question is which distance? Which distance? The shortest distance. I just want to rely on your intuition. What is the shortest distance? Can you tell me if I want to find the shortest distance? I don't say the shortest in the exam. But when I say find the distance from a point to a line, I always mean the shortest distance. But I just want to rely on your intuition without mathematical proofs. If you want to find the shortest distance with the ruler, where should I do that? Yes? Perpendicular, yes. So you take the ruler and drop a line that passes through the point but perpendicular to the line. This is the shortest distance. Why is that is the shortest distance? Let us understand that, because I take this point and I connect this one to this one. Do you agree this is shorter than that one? Why? Because this is a right angle triangle. This is a side, this is the hypotenuse. And we know that the hypotenuse is always longer than any other side. So it doesn't matter if I take that one, if I take that one, for example, this one. Do you agree that this is still longer than that one? The same story. This is a right angle triangle, this is the hypotenuse, and that is the side. So be careful. This is important. You have to know it by heart. I will not mention it in the exam. If I give you a point, and if I give you a line, and I ask you to find the distance from the point to the line, it means finding the shortest distance. And you need to understand what Ismail said. What is the shortest distance? The one that goes from your point in a perpendicular way to your line. Okay, this is the concept. It is not still solved. The problem is far from being solved yet. But we want to do it together. So what should we do? So the question is this one. Okay, so if you want, I can give you a sketch of the graph, even though sketching is not important here at all. But let us do it. If I want to sketch this line, I set up my table, x and y. If x is 0, y is 0. For example, if x is 1, y is 3. So let me find the points. 0, 0, 1, and 3. Yes, so this is my line. This is line L. Where is the point? 2 and 5. So 1, 2, 1, 2, oh sorry, 1 and 2 is here. 1 and 2. 1, 2, 3, 4, and 5. Where is that point? Unfortunately, I don't know where it is. I have to be more careful. So this is, if I put 2, it becomes 6. So it is 5. So it is here. 1, 2, 3, 4, 5. So it should be somewhere here. It's a very stupid point. Okay, so if you don't mind, let me change this number to make it a little bit more transparent to you. So let me write it 6 and 5, okay? So then it becomes 1, 2, 3, 4, 5, and 6, and 5. 1, 2, 3, 4, 5. So the point is here. Okay. Now I want to find the shortest distance, or the distance from this point to this line. So what should I do? I should do this. I have to drop a perpendicular line to here and ask, what is this green line? What is the length of this green line? Okay, now I want to hear from you. Do you have any opinion what to do? First of all, tell me, do you understand what is going on? It was a little bit of mess, sorry for that. I drew this line. I changed the point because it was too close. You couldn't see it well. My point is 6 and 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 5. I find the point, and I want to find the distance from this point to this line. but you yourself need to know what is the meaning of a distance from a point to a line. As Ismail said, this is the length of this perpendicular line. But now I want to find it. How can I find it? It's a very classic problem. It's not a very straightforward problem. You need to be a little bit creative to be able to find that. So what should we do? And I give you a guide. This is related to the distance formula. But the distance formula measures the distance between two points, not a point and a line. So if I want to use the distance formula to measure the length of this green line, I need to know the points. Do I know the point A? Yes. So it means I need to know which point? The other one, which is, I call it, H is better for perpendicular. Usually they use letter H. So now you understand what is the goal. You have a strategy. You want to use the distance formula to find the length of the green line. In order to be able to use the distance formula, you need to know the points. You already know the point A. You don't have any problems there. So your only obstacle, your only problem is to find the coordinates of point H. So whatever you want to think about, don't be distracted. Just focus on a way that helps you to find the coordinates of the point H. It is not that trivial, but it is not rocket science either. Okay, do you have any strategy? You can talk to me, we can fix it, and then we can improve. Do you have any idea how can I find the coordinates of H? Yes?
You can see that it's kind of a right angle triangle, so you can use the third line in Pythagoras and use Pythagoras theorem, and then you can isolate.
Yes, that I'm not saying it is wrong. It probably will work. But it becomes harder if you want to solve every problem in that way every time. Because might be you are lucky, you find these triangles and it will work. Can you solve the knowledge of analytic geometry, not the Pythagoras theorem and things like that? I'm not saying it, I didn't hear from you what you're saying, but I'm sure that if you sit down and think wisely, you can find a way out of it. But then, if I change the line and if I change the point, then you have to sit down again and find a new way for solving that new problem. But now the method that I want to describe here is the method that will always work, independent of where A is, independent of where the line L is located. I want you to solve it algebraically. This lesson is analytic geometry, using the power of algebra to solve geometrical problems. How can I find H? Okay, let me ask you one question. Can you, if you in your head, you don't need to do it, but in your head extend this, it becomes a line. Yes? Can you write an equation for this line? To write an equation of a line, what do you need? 2 points, one method, which is not useful here because I have only 1 point. So the method of 2 points is not useful. The other method that we learned in Math 1C was what was that? The slope and a line. Do you remember? I told you that because if you have a line of that type, it should be of this form. If I can find k value and if I can find the m value, I am done. For the k value, hopefully you understand that you can do it immediately. Can anyone tell me what is the slope of this red line? Exactly, not approximately. It was in the review. I erased that, but in the beginning, I talked about something in the beginning from Math 1C. I want you to tell me what is the exact value of the slope of this line based on this piece of information that this is 90 degrees. Yes, Ismail? No,
-3.
no. A little bit of mistake, I think. Where did you bring? Ah, yes, okay. Yes? -1/3. Why? Because what is the slope of this line? This is the equation of this black line. So what is the slope? The slope of this line is k number 1 is 3. But these two lines are perpendicular. So the slope of this line, k of AH, is not known to you. You need to find the slope of this line. The slope of this line is 3. The slope of this line is not known, but you know they are perpendicular. What did I remind you today in the beginning? The k value of AH multiplied by the k value of this one should be -1. K value of AH is not known to me, but K1 is 3, so it becomes 3 KAH, which is -1. And I want to isolate that. So KAH is what? -1/3. So the K value is found. Okay. But then I am not solved yet because I need also the M value. So do you remember in Math 1C? We write y is equal. Instead of k value, I put this number. And then still m is missing. Do you remember? How should I find? This is a very standard problem. If you have forgotten, just listen to me because it's extremely important. If I give you k value and I give you a point, you should be able to write the equation. For the k value, you just put the k value I gave you. For the m value, what do? Do you remember?
Y equals to 0. Right?
No. Yes, y equals to 0, but what is x then? It is not useful for finding m. What should I do?
Well, the x value should be 0, right?
No, this line is passing through this point. So the coordinates of the point should satisfy the equation. The coordinates of the point are 6 and 5. And it is on this line. So the coordinates should fit the equation. It means that instead of y, I can put 5. Instead of x, I can put 6 plus m. This becomes -2 plus m, so m is 7. So now I have my equation. So this is equation for which line? Line AH. Yes? Then what? Now I have this equation. Yes? And I have this equation. But my goal is to find h. Don't forget the goal. The goal was to find h. Can I find h now? Hello?
Yeah, if you find the intersection first.
Intersection? Because that is the intersection between these two. So what should I do to find the intersection? I have to solve the system. One equation was given to me from the beginning. Y is equal to 3x. And the other equation, I found it myself. Yes? And then what should I do? I use the method of substitution. For example, instead of y, I put 3x plus 7. I multiply everything by 3. So it becomes 9x is equal to minus x plus 21. I move this to the other side, 10x becomes 21. So then it means that x is 2 comma 5, 2 comma 1. And if x is 2 comma 1, I put it here to find y. So y becomes 6 comma 3. The reason I am using decimal points because these are exact values. Okay, can you tell me what is h now? Do I know h? Yes, this is the x coordinate and this is the y coordinate. This is my h. None of it was today's lesson. All of it, this system was Math 2C Chapter 2, and the previous ones was Math 1C. We haven't used today's lesson. Now I want to use today's lesson. How? To find the distance between A and H. Yes? So what do? I write AH is equal to a square. This is the new formula we learned today. Squared, squared. How should I fill it up? With coordinates of A and H. The coordinates of A are 5 and 6, 6 and 5, sorry. The coordinates of H are those numbers, 2, 1, and 6, 3. Okay, so then you put this in your GeoGebra or whatever. So what this number is 4, 3, 9 to the power of 2. And this becomes minus, but minus to power 2 is plus, 1, 3 to power 2. And then you put this number in GeoGebra and you find the answer. Yes? So you see, it was not straightforward. This is why it is important to make sure that if a line is parallel, because if it is not parallel, then you are in this trouble. You have to go through all these gymnastics to be able to find that shortest distance, which is playing the role of the height. Yes? But anyway, the bad news is that this is a little bit lengthy, but the good news is that it is always the same. What I can change is the numbers. But the method will be exactly the same all the time. Okay? Okay, first let me know if you are confused or you don't understand one part of it. And is there something that we don't understand? So let me review. Let me just review the method. So what we do, if I give you a line and I give you a point and you want to find the shortest distance, what do? Because, so you see the coordinates A and B are given. This is the question mark. And the line L is also given. So I give you these numbers, I give you the equation L, and I want you to find the question mark. So what was the method? Okay, so let us review together. What was the first step? You read the K value of L. This is given. Because if I give you L, you can read K. Now you have K, you can read the K of AH. K of AH is now found. Why? Because it is minus 1 over that K. Okay? So when you find K, you have point A, you use the method I described here and in Math 1C, you find the equation of this line. This equation has this as a slope and passes through the point. So you can read this equation. Now you have this equation and that equation, you put them in a system and solve. What you solve is the coordinate of x. And now use the distance formula, square root of these two, to find this answer. So you have to understand the method. I told you this is a little bit lengthy, but this is always the same. So I want to give you one example and wait for you. I want you to reach at the exact value and give me the answer. Okay? So this is the only important and hard part of today's lesson. Okay, so be always observant, you know. If one line is horizontal, use the trick I told you before. You don't need to go through this lengthy way. But if the lines are not horizontal, this is more or less inevitable. So you have to follow this. So let me write this example for you, and I want to wait for you, and I want you to find the exact value without any calculators. I design the numbers in a way you don't need that. Determine the exact distance from the point A equals to -1 and 2 to the line L with these equations 3x plus 4y, and let me make sure that -3 equals to 0. Yes, I want to wait for you. You see, it is not creative anymore because you just need to follow what I told you. So it is 3x plus 4y minus 3 equals to 0. Could you solve it or not? Yeah, it takes some time, but we don't have time. You tell me, I will do. What is the, when you see this problem can only be changed by numbers. If I give you a point and a line, the strategy is always the same. The algorithm is always the same. So you can, if you have forgotten, you don't need to memorize. You say that, okay, I have this line, I want to find the shortest distance. You need to know shortest distance means the perpendicular line. You know that you need to find h. To find h, you need to find the equation of this line. To find the equation of this line, you need to find the k value of this line. The k value of this line, you need to find the k value of this line. So that is the algorithm. So you tell me, I go here and find the k value. So what is the k value? Do you remember Math 1C lesson? How can I find the k value? I have to isolate y. So I move this to the other side. And then y becomes -3/4, x plus 3/4. So what is the k value here? Yes? So it is not, by the way, that long. The reason that you find it long because you want to write everything. Can you tell me what is k of h? K of AH without writing it down. You know it should be a number so that after being multiplied by this, it gives you -1. So what is that number? For example, if I give me a number multiplied by 2 becomes -1. You tell me, what is that number? -1 over 2. Yes? But then it becomes, if I want to find k of AH, I multiply by minus sign. It is gone. I just change the order. So it becomes 4 over 3. That's it. Why is that? If you don't want to do it, it is hard. You know, you have to write KL multiplied by KAH is equal to -1 every time. But after you understood it, do it quickly. K of L is -3 over 4 is equal to K is equal to -1. Then K of H, AH becomes -1 divided by -3 over 4, which becomes 4 over 3. Instead of so much writing, just simply write 4 over 3. Multiply by minus sign and change the order. This is K of A of H.
But that's when you can maybe make a mistake.
Yes, of course. I mean, no, the risk of making mistake here after all these calculations is hard. That's up to you. I'm not motivating you to do that, but sometimes writing so many things is not very useful. Okay? And now what is the next step? You need to find this. So you need to write y is equal to k that I found plus m. M is missing. How can I find m? I would say that this line is passing through the given point A. And the point is given, so the coordinates will satisfy this equation. So instead of y, I put 2. Instead of x, I put minus 1. So it becomes minus 4 over 3 plus m. Because it is fraction, I get rid of fractions by multiplying by 3. So this becomes 6 is equal to minus 4 plus 3m. I move this, it becomes 10 divided by 3. So m becomes 10 over 3. I have to keep the exact value. So then I have my equation. So it is 4 over 3x plus 10 over 3. The next step is to find the system. The system on the one hand is this equation. On the other hand is the equation given to me. By the way, let me write it in that way. Or if you want, you can write it in that way. That's up to you. Let me write it in that way. And now this is chapter 2. We want to solve the system. But everything is ready. Y is given. I go here, substitute this for y. Sorry. This is minus 3 equals to 0. I put y here. So what happens? It becomes 3x plus 4 times y. 4 should be multiplied here and there. So it becomes 16 over 3x plus 40 over 3. And then I have minus 3 equals to 0. And then to get rid of fractions, I multiply by 3. So this becomes 9x plus 16x plus 40 minus 9 equals to 0. And it is simple. You see, it becomes 25x equals to 31 minus 31. So x becomes minus 31 over 25.
That is a distance.
No, that's x coordinate. This is just the x of h. I need to find y of h and then use the formula for the distance. Yes? Okay, what should I do? I take this number with me and put it back here to find y coordinate. So multiply this by 4 over 3. I don't know why the numbers are so bad. Do you see something make mistake here or not? So that one is minus 3 over 4. That's 4 over 3. That's correct. And then I put that number in. So 2 is minus 4 over 3 plus m. I multiply it by 3. It becomes that. That's correct. And then everything is right. And then here, and then the numbers I put there. So yes. Okay, we have to live with it. Okay, of course I can provide you with calculator if you want to, but I have to find y as well, which is very bad. I have to multiply this number by 4 over 3. It's minus 1 over 24, 75, and then plus 10 over 3. Okay, so let me do it in my head, because there's no time to explain that. So I multiply this by 25, 250 minus that one is 126 over 75. So that I can divide by 3, 25, and 42. That's why. Now these are the simple details. You can just do it yourself. So then what do I do? Now I have h. So h is what? Those are a little bit bad numbers, but anyway. Minus 31 over 25. And the other number is 42 over 25. That's it. And now what I need to do, I need to find the distance from A to H by the formula we learned today. So that is the only part relevant to today's lesson. And that is the square root of the difference between the x coordinates. So it is minus 1 minus 3125 squared. Squared. Yes, and then plus the other numbers. 2 minus 4225 squared. I am a little bit lazy. No, it's not hard. So it is 31 and then 6 over 25. 36 over 25 squared plus, and this one is 64 over, oh, the numbers are very good, approximately, yeah, it's very strange. So then it becomes 100 over 25 squared, which is 10 over 25, which is 2 over 5 only. Yeah, it was very strange that the numbers at the end turn out very friendly. So that is the distance. Yes? Azbulat? Yes.
Wait, so you just added the...
Yes, I did all the calculations in my head, okay? But if you do that, that's not a big problem, yes? So what you do, this is the method. You use this to find k value. You use the k value to find the k value of the missing line. You use this point to find the m value of the missing line. You put them in a system, solve the system, find the coordinates. Of course, if I want to give this in the exam, I will sit down and solve it myself to make the numbers friendly, or otherwise I will give you access to the calculator, okay? Any one of them. But the method is the same. When I found x and y, I have h, I have a, I put them in this formula that we learned today, and then I calculate the answers. I did all these calculations in my head, and the answer is 2 over 5. Yes? Yeah, I think it's a good time to stop, but I will also teach you how to use GeoGebra to find these things later. Okay, thank you.